And go. Okay, class, let's go with it. So on your calculator, make sure you go to mode. Make sure you go to mode, and it is in degrees. We're good? And then we have graphed the sine function. Let's graph the cosine inverse function in degrees. Now, real quickly, got to think about this here before we do this. Think about what is my domain here and what is my range. We're talking about sine inverse. We're talking about sine inverse now. Before we graph it, what's my domain for sine inverse?
Negative pi over 2 to pi over 2.
Ah.
Oh.
Yeah.
I sing Jeopardy. Da, 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 da.
What is domain?
Da, da. What you're gonna plug into it.
It's all real numbers.
Da, 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 da. -1 to 1. All right, so remember the output for sine is -1 to 1. So the input for sine inverse -1 to 1. What is the range?
Is the range like 5?
Yes. Okay, so we're in degree mode though. Answer is
Negative 90, 99.
-90 degrees to a positive 90 degrees. That is my range. So now let's go for it before we graph it. Got to get our window set well. Da da da. So we go here. Oh, we don't go. Yeah, we go here. And those that have a calculator, let's go with it. Those that need a calculator, we have 2 in the back. Anybody need a calculator? Raise your hand. Go on, let's go twice. Cool.
I can't get it. I can't.
So we calculated this.
Well, let me pass that up there.
People love this calculator. I don't think this story when I was probably like tonight. Like someday I'll bet you that.
That's so cool. So let's go. Y equals. Make sure that everything's gone here. You need to erase it if you need to erase. And then we're going to go to second function sine of x. Done. But now we go. I got to do this here. I got to go back to my domain. Sorry. I got to go back to mode here. Make sure we are in degree mode. There's that. There's that. And then now let's go to window. So Y equals, yep, Y equals, it's going to be this yellow button first for the second or the shift key, and then that. So let's go, window is X min. X min, -1 to 1. By tens, I don't think so. Maybe like by 0.5, maybe-ish at the most. We good there? But it's the tick marks that are on the bottom. Okay, then we go from Y minimum. The result is, now let's leave it just a little bit more room, right? Because we can have just a little more room there. So I'm thinking like maybe like -100 and then a positive 100. And that's probably for sure by tens at this point, right?
Why? How much riz do we need?
Yeah, how much? Just 1 riz. That's all we need. That's all that's needed. It's going to go down the road, but I'm not going to do it because I'm supposed to be the adult in the room. Okay, are we good there?
That's great. I saw him wearing it, and I was like, "There's no way you switch before."
And graph it. Let's see what we got.
Hey, but I appreciate a man of his word. It's honorable.
That's true. Very true. Okay, class, that is the inverse function graph. It looks like this. That's it. It doesn't go off to the side, doesn't go up anymore. It's just there.
Shade res.
Whoa. Katie, you have extra riz.
You'll stay away from Katie's.
Yes.
She didn't touch it.
You watch her. The window screen has oxidants.
Part. Where's you grab my feet? You know, just come for me.
I love those cigarettes.
You know what do you grab? You tell me what I do. Tell me what I do.
Oh, like resolution.
Tell me what I did.
You do like just
The default is 3.
Oh.
and then just Then we're gonna go back to we firm now or no.
All right, class, are we good there? So that is the graph of the inverse sine function. And if you want to see it a different way, it looks just like this. Going up here.
It's fun.
Look at this. There's my graph right. Does that look like what you just draw on your?
Yes.
Cool. What I need to know is this. As we're jumping back and forth here, I need to know, using the calculator, can you find the value of this? So, exercise 8, using the graph of y equals sine inverse of x, find, and then we'll do a here. A, find sine inverse of a 1/2. So your calculator, this, yeah, go ahead.
Plug in the second one.
You could do it by, sorry, Caitlin, say again.
Well, maybe I'm being stupid, but could you go to the y equals screen and plug in a second y equals, like y equals sine inverse of 1/2 instead of sine?
You can do that way. You graph this way, then you got to figure out the intersection point. There's one little faster way of doing it. So let's do the faster way here. So real quick here, your calculator. The cool thing about your calculator is it actually will calculate stuff. See this little calc stuff right over here above trace? So if you go second and you go calc, and you'll have all these different things right here. And one of them is value. Well, good. Click on value.
Yeah.
And you're going to punch in 1/2 or 0.5, whichever you like.
Oh, so supposed
And
to
you're going to click enter, and it'll tell you exactly what it is. And what is the degree value? 30 degrees, absolutely. All right. So technically, yes, there's a unit circle understanding of it, right? We're doing the unit circle. There's also the graph portion of it that we're doing as well. Right?
You got a second.
Love that.
Value. Enter. And then put in like 0.5.
0.5.
Sweet.
Oh,
But it say 30 there. It says 30, yeah. So technically, yes, we think back to the unit circle, but specifically, what we're doing is we're really looking off this chart right here. So now, see if this makes sense. Let's do one more. No, two more.
once it's never.
I need to know sine inverse of negative square root of 3 divided by 2. Of course, I make it a little more fun.
Unit circle to find that?
You could use this unit circle. You could use the graph, right? That's what I'm trying to teach you. There's different ways to it, right? The unit circle, you have to understand that you're only looking at quadrants 1 and 4.
But does it matter which one we use?
No, essentially, as long as you know that we're technically doing we're trying to figure out the graph technically, but we're doing it in terms of unit circle, right?
Yes. We're not wrong.
It's just like
Fractal. Mhm.
got the graph.
So we go second value.
Second out.
So negative square root
Put in the X you want to see.
of 3, close off that parenthesis, or else you'd be dividing the 2 inside the square root. You want to divide the 2 outside the square root. Are we okay with that? Can you do this?
Or 6.
Value. Oh, so calc. So yeah, second function. Go here. And click enter. And now put in negative square root of 3. Don't forget to close off that parenthesis. The fancy calculators, you guys don't, it actually does it automatically for you, right?
Yeah.
It puts it inside the little root. Okay, anybody got an answer yet? Negative 60 is perfecto. Okay, negative 60 and negative 1.2.
0.2 value.
Ha ha ha.
So the second value. And
It's like you're tricking us. Yes.
Error.
It's because it's outside.
Yes, perfecto. Remember the domain is.
Quadrant.
You need to click on quit when it does it, right? Quit.
Quadrant.
If you click on go to on the calculator, it'll go to where your mistake is at. We're good. If there's any time that you guys have issues there, like, hey, I'm still trying to figure this out. Go to number 2 because you're trying to figure the mistake. We already know where our mistake was. So we can just say quit. Quit will take you back to your home screen though, okay? It kind of just cancels all the execution files that are happening. But yes, negative or 1.2 is a little bit beyond the graph, but there's no beyond the graph up here, right? So there's no such value. So invalid. So trig functions can be valid and invalid. That's cool too. So what do you guys say? Not possible, no answer. What would you guys like to say? No solution? Actually, solution means you're solving for something. So and
Syntax error, not applicable.
we can no
Wait, do it.
answer.
Are you going to tell us now?
Maybe.
And is the reason because this?
Oh, your question was, does it work in other quadrants, right?
Yeah. But this is because it's in quadrant 2.
This is because the sine inverse function only works from -1 to 1. That's why.
Yeah, and that's
Stuck there.
in quadrant 2, and we can't do stuff in
Quadrant.
2.
Correcto. Yep. All right, let's go with it. So we're good with that. Yes. Okay, now one more thing. So now let's do just a little bit of just plugging in stuff here. I need to know, this is exercise number 9, I believe. Is that right?
Yes.
Sweet. And I'll just say simplify. Simplify. That's it. And we'll see if we need another one here. Let's do sine because we're dealing with sine anyways. 3 absolute value of cosine theta. That's what I want to find. If theta is equal to cosine inverse of pi over 4. So some algebra.
I think it's cool.
Define cool, right? Is that okay? So let's plug in like we normally do. We just plug in values. Is that right? So theta is that. So we're gonna put a big old parenthesis here, and that's gonna be this right here.
It's interesting. It's super cool.
And which is this right here. And so, and then absolute value, whatever that's gonna be, and then we got the answer. Too fun. All right. Anybody want to try anything here?
So you could find out what cosine of cosine inverse of pi over 4.
All right, you can try that. Go for it.
Is that not the right thing to do?
That's cool. What is the? Oh, you have to have a unit circle. I forgot to print out more unit circles for you guys here. So you know what? Actually, yeah.
Yeah. No, I didn't. No, I didn't. No, I don't think it. I think we just find out what the cosine inverse is and then use the cosine inverse
if you need it.
to find out what three cosine is. I feel like I've answered.
Oh, question? The circle door. It went a different direction.
I only have 4.
It turned a corner.
Why can't you realize? So
Oh, truce.
2 over 2. So 3.
Ways, and they were different, but like only by thousands.
Find pi over 4.
So I got it is the same that 0.36 billion times. I'm trying to I grew up confused because I think it just cut off there. I think you're
No.
What is that thing called?
No.
what?
No.
It's rounding. You're going.
Oh.
Because you're going slow. Yeah. Oh, there.
Okay, so on plan.
All right, let's go.
You find out what this is, which is 45 degrees, and so then you have 3 cosine of 45. Okay, so let me show you how you with absolute order.
I'm not sure.
So I go pi over 4.
Try to do it without a calculator.
Without a calculator, and it's root 2 over 2, but we're not.
So using a unit circle, anybody know what is cosine inverse of pi over 4?
45.
45 degrees. Okay, what is cosine of 45 degrees?
Root 2 over 2. Or that. Oh. How do we get to 45?
Sorry, class. I messed up, no wonder. So here it is again, one mistake per day. That's what I get. You guys ready for this? Here, that little pi value. So you can't have cosine inverse of pi over 4 because cosine inverse gives you values of pi over 4. We're good? So let's do it correctly. Let's do it the correct way. It happened last time as well. Yep, I am not doing too good there. Okay, that's what I want. There it is. And let me fix this one over here. Doo-doo, doo-doo, doo-doo. Now we're cool like that. Sorry about that. Sorry about the pi over 4 thing. I did not dare. It was a mistake. Okay, we have ourselves variables now. We good? X is a real number. And we have that. Do-do-do-do. So, thank you so much. That's what I was waiting for. So real quick here is if you have a function and then you have its inverse function, what happens to those two functions?
They cancel.
They cancel. Absolutely. These two right here should cancel out. And when they cancel out, they have this. Now the other thing is, x divided by 4 inside an absolute value will be positive forever. And the answer is this right here. Are we good? Because I messed up. I put pi in there accidentally. But it was supposed to give us why would not. Oh, yeah. Yeah, sure. Yeah. The one I messed up on, right? When you go like this, cosine inverse of pi over 4, that is an angle measurement, right? So, but what happens is this is the answer. The answer is angle measurements of that. So if I wanted that, it should have been that. Right?
That. Yes.
But it was just a 4. 4 was actually coincidence. That's all. Okay, are we good? Good?
Being fashion.
Fila. No.
Disgusting and I hate it.
Okay, so let's go with some more here. Example 10 to finish up here. And it's just going to say evaluate. Oh, and then we're going to say evaluate without a calculator.
I don't,
Why?
I'm not pointing to them. No one's talking about you.
I'm very concerned that this came up.
I'm pointing at Fila.
Let's go, guys, real quick here. So now that we know who's the one that said the two canceled. Adrian, did you say they just canceled each other out? Karis? Yes, Karis, thank you so much. So, there you go. I knew there was something that was on this side over here that happened.
Sign language.
So real quick here, all. Here it is. So the answer to this one is
3/5?
3/5. How come?
This
Because the function and its inverse will cancel themselves out. We good? Answer is 3/5. Now let's get more complicated because it's fun to get more complicated.
Let's keep going.
Oh yeah, let's see. Yeah. Yo.
You what's the value on track?
You can't.
Is that possible?
Yes, there is.
How?
On the you guys want to know. I want to know. Okay, side question, a tangent question. So how do you put absolute value inside a calculator here? There is, let me just check. Answer, and let's do one here. So I need the absolute value of -7. Is that right? So you have this little math menu right here, math. And you have something called numbers. And you have abs. Abs.
What do you?
I don't know where that came.
Hey,
Oh, sure.
The abs of -7.
Where did the first thing come?
It would be 7.
That is
So math and numbers.
Not that is. Oh, I'm stupid. Also, my calculator is off.
So the math menu has a lot of different functions that are not on the keyboard. Good. That's what the math menu is for. So notice you could turn things into fractions. The thing. What's the thing? Sweet. All right. It actually even does the line. That's cool. Okay. You can change things into decimals. Yeah. We'll go there. Yep. And then you could take the cube power, cube root, any kind of root whatsoever in the whole entire world. You can find the min and maximum of a function, the derivatives, the integral, and then you do have a solver function.
CR.
Oh, sweet. Okay, then the numbers. Numbers we can do? You can take the absolute value of a number. You can round a number. You can take the complex part of a number. You can take the function part. You can figure the integer that's the closest without going over. Minimum, maximum. Ooh, LCM. Do you guys remember LCM in fourth grade? Lowest common multiple. Oh, there it is. And what's the other one?
Greatest common denominator.
Greatest common denominator? No, greatest common.
Similar tree.
Greatest common divisor. Divisor.
Oh no, how it's not divisor.
It's not
It is divisor.
It is divisor.
It's a divisor.
It is
a
divisor.
hat.
All right, and then we have complex numbers. There it is, complex numbers. Oh, remember algebra 2? You guys dealt with I, square root of -1. There it is, guys. There's a conjugate of it. There's the real part, imaginary part, angle, absolute value of it, rectangular polar, and polar coordinates. Probability. Do you guys ever do probabilities?
Oh, I'm so bad.
I don't know
So, which one?
would be better.
Never tell me.
For probability is like what you could possibly have. Yep. Okay, so we have
That was I like stats. I would have liked geometry if we had it.
NPR. Public radio.
Super easy and what this, that would be hard and awesome, but
No.
So NCR. NPR is National Public Radio.
Truly,
That's just you.
you know that? How is it? I'm not.
And then
I
good. Algebra 2. Algebra 2. Did you guys deal with the exclamation point?
I would have liked geometry
In
if we
Spanish, I
had
mean,
What's up?
Upside down one and right side up. In math, there's also an exclamation. What does exclamation point mean in math?
multiply by itself. Like, dude,
What's it called? What's the name of it?
Yes, that's great.
Keep multiplying. Yes, so 5. It's 5 times 4 times 3 times 2 times 1, right?
It's like what's
The one that you take like
It's called factorial. Factorial. All right, class. Let's go with it.
we didn't do stats is useful.
you gotta learn useful math.
Yeah, let's go.
Stats is useful.
Stat was useful. Absolutely.
not gonna.
Okay. I'm gonna -4/5. Answer is
That's
-4/5 is
-4.
-4/5. Awesome. What? Sine function? Answer function? 4/5. 5/4. So let's go with that one, right?
So you're like,
And this one.
Yes.
I tricked you. I love it.
why.
Love it. Love it. Trick it.
2-5.
Wait, no answer.
No answer.
There you go.
Okay, no answer because it is outside of the domain for the inverse function. Is that right? Oh, yes. Okay. So,
Where'd that come from?
so you have to be in the domain. So no, let's talk about this here. The only restriction for domain comes here, right? And the domain restriction is from -1 to 1, right? Now for the sine function, these guys, any domain issue for sine? Any domain issue for sine? No. Sine goes from infinity to positive. You can plug in whatever you like into that, right? So now if you go like this, sine D, it's supposed to be G. So let's go the other way now. Sine inverse of sine. Now you can do the same thing with cosine, right? And this would be, let's go pi/4, since for some reason pi/4 is a favorite today. Even if it's a mistake, it's still a favorite. Pi/4, awesome. Yes.
Sine inverse of sine, and you put 5/4 in there. 5/4 would it work? Because
Right.
you have anything you could find. The domain issue does away.
Yeah.
Let's try it.
Wouldn't that work? Because you flip it, so it's. I feel like you know from a big.
Sometimes what's the point of you telling us this?
So let's see. So remember.
Yay.
Okay, let me ask myself that every day.
So remember, let's talk about it here. So let's do the next one as we go. So 5/4 is good, right?
Yes.
We can do what? We can cancel this and this, is that right? And notice it's also, hold on real quick here. If I do sine of pi over 4, am I going to be within the domain of negative 1 to 1?
Yes.
Yes, you have to be because you'll be taking sine of that function, right? And then when you get the output of this has to be between negative pi over 2 and pi over 2, right? Because I'm looking at the range, right? So now the question is this pi over 4 inside this range? Yes, the answer is pi over 4. Now let's do another one that's outside the range. We're good? So this is a bit more complicated.
And the inverse, right?
Say it again.
And the inverse has a range of more than or a domain.
Yes, yeah. So that one we don't worry about. Okay, let's do that one. So for Caitlin, ready? Each. Now we go to this. Da, 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 da. So sine inverse of sine. And now let's go to 5 pi over 4. Boom, boom, boom. Adrian, was that Pierce?
Oh, come on. It says
That's convenient. No alcohol.
Okay.
Disappointing.
Okay, so let's go with 5 pi over 4. Now the question is this. If I get a value here, right? Sine of 5 pi over 4, is that number going to be between negative 1 and 1? Guys, real quick here, kind of important here, real quick here, because after this, or you get lost. So you're going to get a value between negative 1 and 1, is that right? The output value of sine inverse is between negative pi over 2 and pi over 2. Now the question is this, is 5 pi over 4 between negative pi over 2 and pi over 2? No. Okay, so here's our little problem. Is this guy here, right? This guy here is going to limit the output as well. We're good? So, like we said before, that's what we're talking about. So domain problems for an inverse function is this. Range issues, it has issues, is from negative pi over 2 to pi over 2. Good?
Why is the second, the original sign, negative 1 domain?
Oh, yeah. So when you output, right?
It has to be line inverse.
this was a
Oh, sure, yeah.
Because you can't grab, because even if like that on its own would work, because it's in another fine thing, it doesn't work.
Yeah, so maybe. Let's see if I'm going to do it. So remember from here, this one, right? This one gives you the input into this right here, right?
Yeah.
So the input into sine is from negative infinity to positive infinity. So we don't care about it going into the sine function.
Okay.
We do care about going into the inverse function because then we have domain restrictions
Even if it
and range restrictions.
doesn't, because the overall inverse sign has limitations.
Yeah, correct. Yeah, and it's the inverse sign that's the issue. Okay, so class, let's go with it here. So back to unit circle. You guys have a unit circle in front of you. Tell me real quick here. Where is 5 pi over 4? Which quadrant? Third quadrant. It is like right over here. True.
Mm-hmm.
This is 5 pi over 4. What we're trying to do, because sine inverse only works here to here, right? And it's from negative pi over 2 to pi over 2. So if you were to keep the y value exactly the same, right? Whatever it is, right? Whatever the y value is. If I were to keep the y value exactly the same, and if I were to transpose this back into quadrant 4, tell me what the angle measurement will be if we go negative from here. Well, that's a lot of information.
Angle in degrees or angle in radians?
In radians this time.
negative.
Radians. 4.
In radians, because we're in radians here.
Pi.
Almost. Negative pi over 4. Are we good? Isn't that kind of crazy here? Because we don't. Kaylin, you're doing okay. You are learning. That's what you are. Mm-hmm. If you knew this stuff, you would not be here. Ha. Yeah.
That you get around the domain issue.
Yeah,
to
correct.
make it fit into the.
What you do is you want to make sure for sine, you want to make sure that the y value, there's a y value here, right? There's an x and y. You have to make sure that that y value is going to be the exact same y value as over here.
Just change the sign of the x value.
It will change the sign of the x value. We don't care about the x value because we're dealing with sine. Mm-hmm.
In the right quadrant is to change the
x
sign of the
value.
x value.
Once we're in the correct quadrant, then we do what we did before, which is figure out my angle measurement, either going positive or negative. We good?
What? I have two questions.
Sure.
Well, first question is, how do we notate that we did that? Like, how does that allow?
So you can either do it like this and say, I'm done because I'm super cool at that. Or what you can do is you can say, I'm gonna actually take the value here. And anybody know real quick here, what is the value of sine of 5 pi over 4 on your chart?
Negative 1 over pi over,
Negative 2/2?
square.
Negative root 2 over 2?
Struggle.
Negative root 2 over 2. Or negative 1 over 2. Yeah, either one, right? Once we do that right there, right? So we've notated that we evaluated this part right here, right? So then the sine inverse of a negative root 2 over 2 is, and now you're looking at quadrants 1 and 4. We good?
Yes.
Because that's the only time that this works. This only works in quadrants 1 and 4. And now we get pi over 4. Okay, Caitlin, is that good there?
Okay, that makes sense.
Sweet.
The
Second question.
why do we when do you decide to switch the sine inverse and the sine? Because in A and B, we were doing sine inverse of the number, and then we're doing sine inverse of sine numbers. So how do you decide when to switch?
Perfect. The homework is going to interswitch them all the time.
Oh, so we don't have to decide. It's just going to do it for us.
Homework's going to say, hey, this. Okay. So let's switch to cosine. Let's switch to angle measurements or degree measurements because it'll be easier here. Let's go with I need cosine inverse of 1/2. Question. Can I cancel those out or no?
Yes.
As long as it's inside the domain, right, of negative 1 to 1, those guys slash out or crash out, whichever one you want. Okay, and then we go like this. So we have cosine inverse of 1.5. No answer is correct.
It's just no answer. There's no way to take it.
There is no such value for an inverse function of 1.5. Cosine inverse 1.
But
no possible.
it was a degree value or like a radian, one of those radian things, like a pi over 4, then we could figure it out by changing the.
Normally right here, this stops here, but if I flip the red cross, which I'm going to do right next, I'm going to do this, right? In this case, it is possible. It may not be the same number as here. We good? So let's go with easy one first, then we'll go to not the same number. We good?
Well,
Too far.
So, right, this one failed because the domain issue failed, right? This one failed because of this part right here, right? Okay, this one, let's see if it failed or not. 3 pi over 4. Is that within the domain of cosine inverse? I'm sorry, the range of cosine inverse. So notice over here, we're talking about domain. Over here, we're talking about range because we want to know what the output would be. So cosine inverse in quadrants in
1 and 2.
1 and 2 is 3 pi over 4 in quadrants 1 or 2. Yes, these guys get to cancel and done. Are we good? And then we're going to do a more difficult one. Let's see, same concept here. So cosine inverse of cosine of now 5 pi over 4. So now is that in the range, the range of cosine inverse as output value? No, there's no way I can take cosine inverse and have an output value of 5 pi over 4. Impossible. We good? So now the question is, what would that be anyways?
Well, it would be negative 2 over 2.
Okay, so let's go with it. So cosine of 5 pi over 4, if we're to do this, we'll go over here, right? This is 5 pi over 4. Negative root 2 over 2. Also negative root 2 over 2 over here, right? So now, because we're dealing with cosine, we have to move it into quadrants 1 and 2 without changing the x values.
Change the y value.
We change the y value. We bring it up here. And now we have the same exact x value, which is negative root 2 over 2. Positive root 2 over 2, but we don't care about the y value. We care about this one to be exactly the same. So now the question is, what is this angle measurement now in quadrants 1 or 2? Absolutely. Are we good there? Then let's go back to H just for a second here, just to make sure.
How do you do that in your head, like without like drawing it out? Like do you just when you need a sort
I have to draw it out. Yeah. So if I'm drawing it out, now let's do it here. So if I'm going to this one right here, and I'm drawing this out, and I look to, so I know cosine inverse here. Where's 4 pi over 4? It's 3 pi over 4. I'm in quadrant 2. Cosine inverse works in quadrants 1 and 2. I am happy. All right, good? Because both of them mesh together, and then I can cancel those, right? If I go over here, 5 pi over 4, now I'm mapping it in quadrant 3. I know cosine inverse does not work in quadrant 3. Therefore, those would be some extra steps to do.
So we just draw
Draw it out.
Oh.
Okay, root. And what time we have? 14 more minutes. Let's go with it. And then we go here. What do we have? Hij. All right, how about, oh yeah. No. Maybe so. Let's do the easy one first. Totally. All right. Tangent inverse of now let's put in these guys together. We haven't done tangent for a while. So there it is. Now let's go back to what was the domain for tangent, range for tangent? What? And we're doing different ones now. That's crazy.
Different. But it just needs the sign value.
Now, these in the homework, if you guys will notice on the homework, they're always going to be the trig function of the inverse trig function. We good? So this one, let's do it together. We're going to go all the way back into it was second day. It was Wednesday's lecture, middle of the class. But okay, let's do this real quick on the board because it'll be easier. So on these guys, where you have two trig functions now, they're always going to be trig function of an inverse trig function. We got to be tricky. Super tricky. So if you think about this here, what's the definition of tangent? Tangent is, or we could say opposite over adjacent, right? So if we make our little triangle, it is in quadrant 1. How come it's in quadrant 1? It's positive. And now I also know I could either say this side right here is a length of 4, is that right? This height is a length of 3, and I have my, we're good there?
Yeah.
And if that's the case, what's the hypotenuse? 5. And then my trig definition is, you can say x over r, right? We can do that as well, right? So this is, x, right? X over r, is that true? So what is x over r according to this diagram here? Are we okay with 4 over 5? Are we good? So we go from the triangle definition of the trig functions, right? Knowing which quadrant we're in, to the x and y values, getting our r value, and then applying that to the trig function on the outside. Kind of complicated, guys. Let's try a couple more here. All right. Easy one or more difficult one? What do you guys say?
Difficult.
All right. You said it, not me. Okay. Here. Okay, medium difficulty. How about this? And then we'll do the and then let's do negative. That's right. Let's do that. All right. So first things first, got to think about, because this is putting everything together now. And then we'll do more difficult one. Cosine inverse works in which quadrants? 1 and 2. Because it's a negative, we are in quadrant.
Are you missing a parenthesis or am I just...
Oh yeah, yeah.
Sure. Thank you.
Thank you. We are in quadrant 2, is that right? Next is, what are my values that I now have? We can go directly to the coordinates if we need to.
Y is one and X is but
Let's see. X is -1. Is that right? And the R value is √5. Are we good? Because it is the X value over R value. At the end, what we want is we want the Y value over the R value. And we are in quadrant 2.
So the Y value would be 2. I just did that in my head.
Yep. So if you guys want to do that here, -1 squared plus the Y value squared is equal to the square root of 5 squared, which makes 1 plus Y squared equal to 5, which makes Y squared is equal to 4, which Y being plus or minus 2, depending on what we need. And we need a positive 2. Final answer is 2 over √5. And it is a positive 2 because we are in quadrant 2, because the cosine inverse only works in quadrants 1 and 2. Are we good there? All right. What do we got? Time. Yeah. 9 minutes. A, B, C, D, E, F, G, H, I, J, K, L. L.
beautiful.
Not have the, so sometimes you have extra parentheses, sometimes you don't. This one would be an example you don't. But either way, even if you have a negative, you don't really need the extra parentheses. Okay. Ooh, you know what? Let me change it up. Nah, no, let's keep it like that. Okay. This one, oh man, no fun. We have a cosecant function in our hands. Notice it is not a cosecant inverse function, right? This is just regular cosecant. It's cool like that, cosecant. Okay, so tangent is positive. Tangent inverse works in quadrants 1 and 4. But because it is positive, we know we are in quadrant 1. So we can set this up. We know we have a x coordinate of 4. We know we have a y coordinate of 3. We know we have an r value of 5. And then, so if you want to label this stuff, right? This is the y value, that is the x value. What we need out of this is the r value over the y value. So what is the r value over y value here? 5 over 3. Are we good there? So just a lot of mental process to get there.
This I understand. This I can do.
Okay.
I know that.
All right. Okay, and then I think that's about as difficult as it gets. You just need to know which quadrant you're in because of the inverse function, right? And then what you need to get out of it, right? So L, M. Okay, let's go. Yeah, we probably should do this one here. So let's go with find expression. So this is going to be exercise 11. Is that right? Find it says write the expression. Actually, I should say write the expression. Sorry, write the expression. Okay, this one's going to get a little bit weird. This is the end of it. This is 4.7. So here's what we're at. We're at the end of the chapter, right? We're at the end of the exercises for the chapter. This is where they gets like all put together. We're good? So let's go with it. Even though I think it'll still be cool. So I need to know this. I need to find an expression that will give me this. And x is any positive number whatsoever. Let's do this one. Let's say I don't need the extra parentheses. I keep on doing extra parentheses here. I don't. And so let me read it here. 7. And let me just check something real quick here. 4. Yeah, right here. Nope, 5. 4. 4. We. I'm just checking something out real quickly here. Okay, let's go with it. And I think yeah, two problems here. So all yours here, x is going to be, assume x is positive. For problems, yeah, blah, blah, blah. Assume x is positive number. That's it. So you don't go into the negatives here. Assume that is positive. So real quick here, if I have this set up, which is the trig function on the outside, the cosine inverse function on the inside, and x obviously is going to have to make a value, right? So what's the expression if x is a positive number? It's just x. Are we good there? These two will just cancel themselves out because the domain, the output of this one, right? The output is going to be between
Negative pi over 2 and pi over 2.
from 0 and pi, right? That's for cosine. Cosine works in quadrants 1 and 2. And when I plug that in into this, it can accept all those values and return for me that value there. We good? Okay. So that's the easy one. Next, with a few minutes left, let's do the crazy one. I need to know sine inverse of, what's the sine of tangent inverse of x. In fact, let me do that on the next. Give me okay, 14 minutes left.
So that's the first time somebody actually understood what I was.
No one gets your British theory reference?
Apparently, man.
Yes. That's a darn shame.
No, right?
Her music videos are so good.
I mean, I don't remember watching anything,
But I didn't know it's they're like peak.
Yeah, she's still 7. Yeah. All right. So sine tangent inverse of x. So let's go with it here. So let's see. X is a positive number. We are in quadrant what? We're in quadrant 1 because of tangent. Now x is just x. So is there a number underneath x? 1, absolutely, because any number could be turned into a fraction with 1. What is the y coordinate? Oh, this is going to be crazy, guys. Real quick here. Yeah. No, cannot.
That's really
So the y coordinate is x, right? The x coordinate is 1,
that's like
right? And then we need to get our y coordinate over r value. Is that true? To get out. So what is the r? Sorry, what's the y coordinate?
X.
X. What is the r value? Ooh, let's go with it. So 1 squared plus x squared is equal to r squared. So let's see, 1 plus x squared is equal to r squared. Therefore, x squared, make it nice. X squared plus 1 is equal to r squared. Therefore, r is equal to the square root of x squared plus 1. Are we good? And we go right over here and we get ourselves x squared plus 1. Are we good?
yeah. Yes.
Or if it makes X plus or minus.
Oh,
1.
no.
No?
Can't do that because our value is always positive, right? And we are in quadrant 1 because of the definition. Okay, are we good? We have finished 4.7. Finally. So Monday. So we'll have it due on Friday.
Yeah.
I was just scary.